This is A23, June 05, Physics 6, and these are synoptic questions, and this is a question 5. And it's about digital information storage on a compact disc. And I'll just scan in a wee bit there. A compact disc recording contains 2 channels of digital sound, which provides a stereophonic effect when it is reproduced. The advantage of digital recording is that the original sound wave is described in terms of a list of numbers instead of as a continuously variable quantity, as in an analogue recording. This results in much better reproduction of the original sound. The numbers are encoded as a series of zeros and ones on the disc. The numbers are then decoded at playback to reproduce the original sound. The compact disc itself is made of polycarbonate plastic. The digitised sound is in the form of tiny bits arranged on a long spiral information layer. A typical disc can contain 21,875 individual tracks, which add together to give the information layer. The average distance round the disc is given by 2 pi, the mean radius of the information layer. A part 1. The minimum radius of the information layer on a typical disc is 23 millimeters, and the maximum radius is 58. So if you have a wee look there, I'll just draw this at the side. So there's your maximum radius from the centre, and that's 58 millimeters. And the minimum radius, probably out to the edge of the hole, I didn't draw the hole in, but it is 23 millimeters. Show that the total length of the information tracks on the disc is, to one significant figure, 6 kilometres. Now, the problem is that obviously the radius is going to vary the further out that the laser is reading the information from. And so what you need to find is an average distance for the radius of your information layer, and then multiply that by 21,875. Find the circumference first, of course, and then multiply it by that number. So we're going to find the average radius first, and that's 58 plus 23 divided by 2, and that gives you 40.5, and it's in millimetres. Then we're going to find the circumference. So the circumference equals 2 pi times the radius, which is 2 pi times 40.5 by 10 to the minus 3, and that's in metres. And the circumference of one average radius there, or one circumference, is 0.25 metres. And so therefore the total distance is that distance multiplied by the 21,875 tracks. And that gives you an answer of 5,567 kilometres. Or it asks you to one significant figure, that gives you 6.000 kilometres. The next part of the question, the speed of the reading head along the information track is a constant 1.2 metres per second. Calculate the time taken to read the whole disc. And so speed is distance over time, but we want time, so time is distance over speed. And that's just, I'm going to use my distance I calculated, which was the 5,567 kilometres. And the speed is 1.2 metres per second. And that comes out to be 4639 seconds. And therefore, that is equal to 77 minutes, which seems reasonable if you buy a CD that it would have a time of 77 minutes. You could do this with the number they suggested. If you weren't able to get the 6 kilometres, then you could do it with it. If you hadn't been able to get this value here, and you just used their value of 6 kilometres, if you do it with the 6 kilometres, that gives you 1.2 over 1.2, which gives you 83 minutes. Either value, they're happy enough with either value. I'm just realising this is 5.567 kilometres. And if I just go back to this page here, this value is of course 5.567 kilometres, my mistake. So either time there, they're quite happy with, whether you use your value, which I did there, 77 minutes or 83 minutes, but it should come out as a, you know, a reasonable time, which seems fairly straightforward to you, that, you know, a disc will play for just over an hour or an hour and a half or whatever it plays for. Part 3, for the constant reading of 1.2 metres per second, calculate the angular velocity with which the disc must be rotated when the reading head is at a minimum radius of 23 millimetres. Excuse me. So we're going to use one of our circular motion equations. V is equal to r omega. We're looking for omega, so omega is equal to V over r. And V is 1.2 and r is 2.23, by 10 to the minus 3. Because it's in millimetres, we need to change it to metres. And that gives you 52.2. Part 4. The angular velocity of the disc cannot be kept constant for all positions of the reading head if the reading speed is to be kept constant. Explain why. State how the angular velocity must be changed as the reading head moves outwards. So we know that omega is equal to V over r, and we know that V is constant, but that r is changing. And in fact, r is increasing as it goes from the inside of the disc to the outside. And therefore, if that's the case, V is constant, r is increasing, then omega must be decreasing as the reading head moves outwards.